Okay, we're going to graph the rational function in example 1e from notes 4.2 day 1. We'll begin by factoring the function. The numerator is already factored, so I'm just going to copy that here. Negative 5 times the quantity x minus 1. The denominator we can factor. It's a trinomial that factors as x minus 3 times x minus 1. I notice that there's a common factor of x minus 1, so I'm going to write the simplified function, which we can use later, as negative 5 over x minus 3, where x is not equal to 1. I'll just do that part of the analysis right now. Let's find the x-intercept. The x-intercepts occur when the numerator equals 0, but the denominator is not equal to 0. In this case, it looks like we might have an x-intercept where x is equal to 1, but x equals 1 is excluded from the domain, so we don't have any x-intercepts, none. Okay, the y-intercept, we find that by evaluating f of 0. So f of 0 for this function is going to be negative 5 times negative 1 in the numerator over 3, which is 5/3. So we have a y-intercept at the ordered pair 0, 5/3. That's a 3. Let's find next vertical asymptotes. Vertical asymptotes occur when the denominator equals 0, but the numerator is not equal to 0, or if they both equal to 0, the factor cannot be canceled out of the denominator. In this case, we have a vertical asymptote at x equals 3 with odd multiplicity, but x equals 1 could be canceled out here, and that would not give us a vertical asymptote. So we just have one vertical asymptote at x equals 3, which has odd multiplicity. Next, let's see if we have any holes. Holes occur when we have common factors in the numerator and the denominator that can be canceled out of the denominator. In this case, we have a hole with an x value equal to 1. To find the y value, we need to use the simplified function. So I'll write that down, use simplified function. So we're going to substitute x in here into the simplified function. So that would be negative 5 over x minus 3, which is going to be negative 5 over 1 minus 3, which is negative 5 over negative 2, which is 5/2. So we have a hole at 1 5/2. 1 5/2. Now we're going to look at infinite asymptotes. So infinite asymptote, we're going to look at the degree of the numerator and the degree of the denominator. So the degree of the numerator for this function is 1. So n equals 1. The degree of the denominator is 2. N is less than d. That means we have a horizontal asymptote at y equals 0. And if we really want to think about intersections with y equals 0, that would mean we'd have to have x-intercepts. So we could set the function equal to 0, but we're going to find there's no solution. So there's no intersections with y equals 0 because we have no x-intercepts and our horizontal asymptote is at y equals 0. We have no slant asymptotes because our graph is not going to have both a horizontal and slant asymptote. It can only have one type of end behavior. So let's start graphing our function. So I'm going to put the y-intercept on at 0, 5/3. That's 0, 1, and 2/3. So I'll put a point there. And we have no x-intercepts. I will put the vertical asymptote on at x equals 3. So I'll sketch that on my graph. And x equals 3 has odd multiplicity, so I'll put a little O next to my vertical asymptote. I'm going to graph the hole. That's at 1 5/2. So that's about here, 2 1/2. I'll put a hole there. And now we have to, I need to put on the horizontal asymptote at y equals 0. All right, our graph never intersects y equals 0. And it needs to pass through the y-intercept. It's going to approach the hole. And then on the other side of the hole, it has to shoot up towards this vertical asymptote at x equals 3. Once it goes through the y-intercept going towards the left, it has to approach the horizontal asymptote at y equals 0 as x goes to negative infinity. And then as we cross this vertical asymptote at x equals 3, it has odd multiplicity. That means the graph is going to cross the x-axis. The ends will go in opposite direction. So if it's going upward here, it will go downward here. And then we can sketch our graph because it will once again approach the horizontal asymptote at y equals 0.